Today we are going to discuss about Asian thinking based automatons of aerospace. So before entering into this subject, what is simple aerospace? It is a branch of aeronautical to study about the aerospace vehicles like rocket engines, uh, propulsions, e-surroundings, more that aerospace engineer. So but design thinking with the involves 5 stages. Empathy, define, early prototype, and testing. So empathy means they will give the n number of problems, identify the particular product. Next one is define. So that define will find out the solutions for this problem. Ideate what are all the implementation to solve this problem. Prototype. Finally, we will implement the solution for the how it will be working the product. That is called as prototype, and last one is testing. So in that testing, you will collect the customer feedback. These are all 5 stages. So now the sessions it will be kind of with the students. Students elaborately discuss about the usual stages of DT.
To empathize is to gain a deep human-centered understanding of how different people experience aerospace systems, so engineers can design solutions and address real-world problems instead of assumptions. Identifying the core reasons of passengers, pilots, in cabin crews, maintenance personnel, and ground control systems. Passengers need comfort levels, accessibility, safety precautions, and noise, a fear of flying and boarding experience. Pilots and cabin crew have forfeited ergonomics, workload during takeoff and landing, and maintenance personnel have ease of accessing aircraft components, etc. The points revealed to this empathizing study is to understand how better we can work out our designs so all these people can gain a more comfortable and well-nurtured level of experience during their journey. The different stage where we take everything from the learn in the empathize phase, turn into a clear and crystal clear and the problem statement, focused problem statement. In airspace, this step is very crucial because challenges are complex that can affect the safety, performance, and user experience. Engineers analyze user needs and technical data and consists to identify the real world problems and not just the visible symptoms. And this helps to avoid the designing in the wrong solution. For instance, for example, while saying the instead of saying the reduce the aircraft noise, we define the problems. How can we reduce the takeoff noise by 20% without increasing the weight of fuel? The clear definition gives a direction to the ideate and prototype stages, ensure the entire defined process to be straight, targeted, and effective. After defining the problem clearly, we move on to the ideate stage, which is the most creative part of the design thinking process. In aerospace engineering, this stage encourages teams to think freely and explore a wide range of innovative possibilities without immediately worrying about the technical constraint. The goal here is quantity first because pool of ideas often leads to stronger final solution. We begin with brainstorming sessions where every idea, whether big or small, is welcome. This opens space to creative thinking, thinking across like various disciplines like aerodynamics, material science, propulsion, and human factors. Tools like mind mapping help connect concepts visually, allowing engineers to identify patterns and combine ideas for better outcomes. One powerful method that we use here is the scamper technique, which stands for substitute, combine, adapt, modify, put to other use, eliminate, and rearrange. Through this process, engineers generate ideas such as blended wing crafts, morphing wings or electric or hydrogen propulsion systems. The ideal stage ensures that aerospace solutions are not just limited by convention, but driven by creativity, innovation, and collaborative thinking.
In the prototype stage of design thinking, ideas begin to take a physical form or a digital form. This is the point where something begin to you can observe, test, and improve. In aerospace engineering, prototyping is especially important because even small design changes can significantly affect performance, safety, and efficiency. Engineers use rapid prototyping methods such as 3D printing, CNC machining, and computer simulations to create yearly model of components or systems. This prototypes allows team to explore how their ideas behave in realistic conditions without committing in full scale marketing production, such as for example, winglet, a newly designed winglet or fuselage modification can first be modified into a small scale and tested in a wind tunnel to observe airflow, drift, and lift characteristics. By prototyping early, engineers can identify flaws, gather user feedback, and refine their designs quickly. The key idea of the stage is iteration. A prototype is in the test stage. We generally test the equipment which is converted into a prototype. In aerospace, actually, we use it for how the material or object works. This is the main stage which is used to find the error before publishing the material or an object. So we should be careful in this stage by finding the errors and rectifying the errors by an engineer. In general, aerospace test stage is a very crucial thing because if a small error occurs in the aircraft, it may cause very big effect.